Okay, number 5. Again, we want to use the remainder theorem to find the remainder when our polynomial is divided by x minus 6. And then we're going to use the factor theorem to determine if it is a factor. Okay, so our polynomial is here. Now, because we're using a fraction, I'm going to go ahead and do this one with a calculator just because it's so tedious. But at this point, you guys should be able to do this by hand if needed. And so the factor that we're going to be plugging in, you have to remember, you take this linear factor, you set it equal to 0, and you solve for x. So we would have to add 1 over 6. So x equals positive 1/6. This is the number that we're going to be plugging in, 1 over 6. So with a calculator, I'm going to do this. Now, we're hoping to get 0. If we get 0, that means it is a factor. If we do not get 0, it is not a factor. I'm going to go to y equal. I'm going to type in this expression, 6x raised to the 4th, and then minus x raised to the 3rd plus 12x plus 2, and then I need to delete this last one. So 6x raised to the 4th minus x to the 3rd plus 12x plus 2. All right, if you do second graph this time to see the table, you will not see 1/6 because the table counts by whole numbers, 1, 2, 3, 4, so on. So if I want to know what the value is for 1/6, I have to actually tell the calculator to calculate the value. So you have to go second and then calculate, and then we're going to tell it we want to plug in the value. So it's going to show the graph first, and then it's waiting. X equals, what do you want x to equal? 1/6. So I'm going to do 1 divided by 6. When I plug that in, the y value that we get is 4. So the remainder is 4. Is x minus 1 over 6 a factor? No, it is not, because the remainder is not 0. It needs to divide in evenly. So no, it is not. Now, number 6, we want to use the rational zeros theorem to list potential rational zeros, and it says do not attempt to find them because it would be quite tedious. So the rational zeros theorem, and a lot of this you can find in the text. I'm just showing you how to do it, how to use it. Let me move this out of the way. Okay, so number 6. F of x, you have to make sure it is in numerical order. That is, whatever your highest degree, everything needs to count in order. It needs to be smaller than 9 after this. So then we have minus 11x to the 6 plus 7x minus 23. Now, I could be mixing up the letters. I might just pull up the textbook and look for it. I believe they call the leading coefficient here, which is understood to be a 1, as P, and your constant term at the back, they call this Q. And what we're going to be doing is taking this number, Q, and dividing it by P. Let me verify. I do want to use the same because using different things could be confusing. So let's see if this will pull up. It's been going kind of slow. Okay, there we go. Let's find, so this is the remainder theorem that we've been going over. Zero factor theorem. It's the rule of signs. Okay, rational zero stem, here we go. So they have P over Q, but they don't label it as P and Q here. First, list the integers of P. So I guess they do it in different order. They have it P over Q, and they're calling P the factors of -6. So I flip-flop them. So I'm going to flip-flop. This is P, this one is Q. So we do P divided by Q. Okay, so this is it on page 391. You get a full-blown explanation of the rational zeros theorem. Okay, so I just flipped it around. This is actually Q, and this is P. Usually they go in alphabetical order, but it's flipped around here. So this is P, this is Q. Now, P is represented by 23, and Q is represented by 1. What we do is we list the factors of 23, everything that can multiply to give you 23, which is just 1 and 23. Those are the only numbers we get. We list all the factors of 1, which are just 1. And considering positive and negative, we're going to list all of the numerators divided by the denominators. So we will get 1 divided by 1, which is 1. 23 divided by 1, which is 23. Anytime you divide by 1, you get itself. And so this is our list, but we get positive 1 and negative 1. We get positive 23 and negative 23. So if I was actually to spell this out, the list would be -1, positive 1, negative 23, and positive 23. So this would be your list of possible rational zeros. And so it looks like A matches. I don't know if there's other options. It doesn't have to be in order. Okay, so this one would work out just fine.